Well, winter is finally here, so what else to do than sitting by the fireplace and doing some cozy coding? Today is gonna be another Git day, this time with a tutorial for those who want to have a closer look at how Git works internally. So, Git is this tool that seems complicated until you learn that what it does under the hood is not that complex. The best way to see this is by creating a repository and looking inside the .git subfolder. This folder is usually hidden unless you check the Show Hidden Files option in your Explorer or File Manager. At the beginning, there isn't much here. For instance, you will always find a configuration file for the entire repository where every local setting will be saved. Another file we can see is head. It simply contains the name of the current branch, which initially is master, and the path where details about it will be saved, for the moment empty. You can see that if we change the branch in the console, it will be reflected in this file. There is also the hooks folder where you can intercept most of the Git operations and hook in your custom scripts, but more about that in a different video maybe. Then a file called exclude inside the info folder where you can exclude elements from being tracked without having to use a gitignore file. Everything else are empty folders because you just started. So when you are ready to create your first snapshot of the current structure and content of your project, you will use two commands. The first is git add, which adds the files to the staging area. At this point, if we go to .git, we can see that something has been created in the objects folder, which was empty before. It has a quite long name, and that is because Git uses the secure hash algorithm to generate a unique hash of 40 hexadecimal digits based on the content of the file. This is also called hashing. You can test this independently using the plumbing command hashObject with the name of the file. If we change the content, the hash is different, even if it's just one letter. If the content is exactly the same, the hash is always the same. This is how Git checks for duplicated objects. We can also see that each object is stored in its own folder, and the folder name is the first two digits of the hash, while the file name takes the rest of it. But Git doesn't only do this, it also compresses the file using the zlib algorithm, which reduces its size, at least when it's big enough. The final result is a so-called binary large object, or blob. Another thing that you may have noticed is that now we have an index file. This is a binary file, you can't read it in a text editor. It has a specific format and the content can be retrieved with this command. The index is a list of the files in the staging area. We can see the hash of the object and the actual file name. So this is what happens when you add files. The objects and the index are created. At this point, we can still modify some of these files and add them back to the index. You would expect the object to be updated, but instead a new object is created for this change. That's because once created objects cannot be modified. For every change, a new object for the file will be created. Now we are ready to take a snapshot, so we do a git commit. After the commit, we can see that a folder called logs has been created. It was actually created when we changed the branch name, because this is the log of all your Git operations. If we open the log of the head in here, we can see all these details, the commits hash, of which we will talk in a moment, the author, email, and date of the commit. The same information is saved in the log of the main branch log that was also created to keep a history specifically for the branch, which for now is the same as the head. If I change something in the project and commit again, this log will be updated. You can see how each line contains the hash of the previous commit, which will allow us to switch back and forth between commits. For example, here we go one step back, and we have the initial files. Checking out a different commit will also update the branch to which the head is pointing. This is how Git knows what is the current commit of each branch. Now, what if we create a new branch from a specific commit? We can see that the head will now point to the new branch, which is now the active branch, referencing the commit from which it was created. Switching back to the main branch updates the head and restores the commit referenced by the main branch. You can see both branches here. After the commit, we can also see more objects than we would have expected perhaps. First, some might be objects that have been created but not committed anywhere. We can do a git prune so that objects no longer referenced anywhere are removed. The reason we have more objects than files committed is that not only blobs for content are stored in the object folder. To see what type of objects we have here, we will use the following commands. First, to get a list of all the objects from the console. Then, to get the type of any of them, we run this command with the object's name. We can see what's inside the blob object with this command. As expected, is the content of the files. The other types are tree and commit. First, the tree object. We can look inside a tree object like this and see that it is basically a structure or a tree of the folders and files for a specific snapshot, containing other subtrees for folders and objects for files. Each line contains the permission, the type, the hash of the object or subtree, and the real file name or folder. And now the commit object with the same commands. Here we have information about the commit, most importantly the tree for this commit, and then the author, date of creation, and the message. It can also contain the previous or parent commit if it's not the first one. So we could say that in a Git repository we have a head file referencing a branch, referencing a commit, referencing a tree, referencing other trees and objects, and finally the objects hold the content of our files. If we check out a specific commit or branch, its tree reference in the commit object along with its subtrees and blob objects will be reconstructed in our working directory with their real names. There is more to Git than adding, committing and switching branches, but everything is built on top of this simple file system where anything can be referenced and retrieved by using its hash. So I hope Git is no longer such a mystery now and you have an idea now of what's inside the .git folder. Other than that, you would never have to touch this folder. Actually, it is not recommended that you do, and instead use the wide range of commands that Git provides. For now, this is all. Thanks for watching. Leave a like and subscribe to the channel, and have a nice day.